It takes commitment and dedication from farmers to produce a healthy crop. Having a balanced nutrition and water supply is very essential for every living thing, especially in rice cultivation. I'm Carol Gurusamy and this is the Science of Rice. This week we focus on applying fertilizer using the right rate and doing so at the right time. Not only that, but also the importance of having proper water management in your field.
The rice plant requires 19 essential elements for it to grow healthy and yield economically well. And these nutrients can be absorbed from different sources. For example, hydrogen, carbon, and oxygen. These can be absorbed or make it available to the plants through water and the air. And these are more or less required in the process of photosynthesis and so on.
There are 16 basic important nutrients that a rice plant needs. They are divided into two groups, micro and macronutrients.
The macronutrients, these are nitrogen, phosphorus, potassium, calcium, sulfur, and magnesium. Now, nitrogen, phosphorus, and potassium are required in the largest quantities. That is why they are determined as the primary macronutrients. And sulfur, calcium, and magnesium, these are also required in large quantities but less than the primary nutrients, so they are termed as the secondary macronutrients. And because they are required in large quantities, that is why they are being termed as macronutrients. The other elements, essential elements that are required are those that are required in very minute amount, and these are cobalt, silicon, molybdenum, manganese, copper, boron, zinc, chloride, sodium. So these are required in like parts per million or in percentage quantities, a very small quantity. The basic principle here of crop nutrition is that the amount of nutrients that are being required by the crop and the time at which they are being applied or made available to the crop. That is the whole principle of the nutrition of the rice plant.
All these nutrients are found in the fertilizers that farmers are already using. But what is the correct rate at which he needs to apply? Let's find out from the expert.
Nitrogen is the most limiting nutrient in the rice crop system, and that is why large quantities are required. If there is deficiency of nitrogen in the soil, the plants become yellowish and it firstly appears on the older leaves. If it's a young rice plant, the entire plant becomes yellow. This will also reduce the growth rate of the crop in terms of the plant height, the amount of leaf area, the amount of tillering that will produce by the plant. And if there's reduced tillering, that is a negative impact on the yield also immediately, because every tiller of a plant, of rice plant, bears panicles, which will have the grains. So the less number of tillers produced, there's a less yield potential will be realized. So it is very important that we apply nitrogen. And in Guyana, the major source of nitrogen is in the form of urea. Urea carries 46% of the nitrogen. And this is the predominant source, as I said, for nitrogen. So the application rates will basically vary, and that will depend most largely on a soil test. However, if soil test facilities are not provided, then we use the results from previous experiments. And experiments would have been done continuously for different areas and a number of seasons. And the response to the different levels gave us a guide as to how much nitrogen is required to be added to the field.
It is important to note that not all of the urea is applied at one time, but it's recommended to apply urea fertilizer in 3 applications.
Too much of nitrogen applied at once can lead to, one, a lot of wastage. Secondly, excessive vegetative growth. And also, it predisposes the plant to attacks by pests and diseases, especially fungal diseases. So it is best recommended to apply urea in 3 splits. Our varieties are between the duration of 105 to 118, 120 days. So it is required that we split our applications. The longer the duration of the variety, more split applications are required as compared to a short duration variety. If the soil type is loose, let's say for example, if you have a loomy type or sandy type of soil, you can have high amount of leaching losses and so on. And even to runoff losses in flooded fields or when there's excessive rain. So it is best recommended to apply the nitrogen or urea in split applications. So 3 splits we recommend. The total amount of urea applied at the first dose is around 18 to 21 days, where we apply 1/4 of the total. The second application is at 40 to 42 days, half of the amount, 50% of the required amount. And the remaining 1/4 or 25% is being applied around 60 days, just before flowering.
Another important factor to note when applying nitrogen fertilizer is the amount you apply during the wet and dry season.
It is very important that we take note in terms of seasonal effects on the amount of nitrogen being applied. Let's say, for example, well, we know in Guyana we have 2 cropping seasons. And one season may be predominant because of rain and the other one because of more sunshine. In the season that we have more solar radiation or sunshine hours per day, it is recommended that that season the full amount of nitrogen requirement being applied, because solar radiation is the #1 driving factor for determining the yield. However, in a rainy season, there is more cloudy conditions or cloudy days, less solar radiation, and the plant would not be able to realize its full potential in terms of getting higher yields. So it is always advised that we reduce the fertilizer requirement about, let's say, 15 to 20% in a rainy season, as compared to a season where there are dry conditions, more sunlight, and higher potential for yield.
Another important macronutrient is phosphorus. This helps in the development of the plant root and plant tillering.
Timing of phosphorus application is recommended basal or incorporated, or not later than 18 to 21 days after sowing as top dress. So phosphorus is being purchased in different formulation or different sources. Then the major source of phosphorus in Guyana, it is the triple superphosphate. And we have the NPK formulations, which is 8-32-16, and another NPK formulation 6-25-25. So these are the different types of phosphorus sources, and they can be either applied basal and incorporated, that is plowed into the field in the dry conditions, or it can be applied top dress at 18 to 21 days after sowing. The additional benefit of using the NPK formulation is that there's a small percentage of nitrogen which will take care of the early establishment and give the plant a boost in terms of early growth, so that it can negate the effect of bad field conditions, insect pest problems, and so on.
Potassium is the third and equally important macronutrient.
Potassium is more or less referred to as a quality element. It helps with the quality of the grain filling. It helps with water relations of the plant. It helps with the tolerance to resist lodging and resistant to disease infestations, especially brown spot. These nutrients are required, as I said earlier, in larger quantities, and the plants remove them from the soil also in larger quantities. For example, nitrogen is being removed for every ton of grain produced. 15 to 20 kilograms of nitrogen is being removed in 1 ton of grain. Phosphorus, 3 to 5 kilograms is being removed per ton of grain. And potassium, 15 to 20 kilograms is being removed by a ton of grain. So if a farmer wants to have high yield, let's say for example 5 tons per hectare, and we know how much nutrients is being removed by 1 ton of grain. So you need to multiply the yield at which you are looking at the quantity of nutrients that the plant will remove. In addition, we have to cater for nutrient losses, those that will undergo changes in the soil, bind to the soil, and not become available. The amount of potassium required, as I said, will depend on the soil test. However, from our experimentation, the amount required will be about 55 pounds to 75 pounds per acre. And these are just broad generalized recommendations that was derived from series of experimentation. However, some cases where we have soil tests done, there are also large needs for potassium to be applied.
Besides the macronutrients nitrogen, phosphorus, and potassium, there are other important nutrients a rice plant needs.
The general rule here is balanced nutrition. Balanced nutrition means every nutrient must be available to the plant or supplied to the plant in the quantity of which the plant requires. That is, not applying too much of urea and there is no phosphorus or potassium, but applying all of it in the required amount. Because what will happen, if you apply one nutrient too much than another, you would have imbalance in terms of the uptake. One dominates the uptake of the other, and the other one becomes deficient to the plant. And as such, it can cause ill health to the plant. So the other nutrients, micronutrients available, and to a certain extent sulfur, magnesium, and calcium, these can be applied through several sources. And on the market presently, there are different types of product that has different composition of both macronutrients and micronutrients. And these are more or less recommended to be applied in foliar application. And we know that foliar application, there's only a small quantity of fertilizer that can be added at a time. And the amount of fertilizer being required by the crop, we need to do several applications. So in some cases, there may be 2 to 3 applications of foliar fertilizer. And these can also happen at the same time when the granular fertilization or broadcasting of fertilization will be done.
While the application of the nutrients into the soil is vital, the acidity and alkalinity level for growing rice is equally as essential.
Rice grows best under pH of 5.5 to 6.57. Lowering the pH below 5.5, which will be acidic or moderately acidic, can pose problem to the crop. Now, there are certain nutrients that are available under different levels of pH conditions. For example, phosphorus becomes deficient, highly deficient under high acidic conditions. So the more neutral the pH becomes, the more available phosphorus becomes available to the plant. Likewise for other nutrients. At the same time, if the soil is more alkaline in terms of pH, other nutrients, essential nutrients becomes deficient. And at the same time, other nutrients becomes too toxic under the different pH levels. So we need to amend these soils so that the pH level becomes ideal for proper availability and uptake of nutrients. Now, in the event of acid soils or soils of low pH, liming is important. That is, applying limestone to the field. And the amount of limestone to apply per acre will depend on what is the present pH status of that soil and what is the target pH we want to change that soil to be. And that could be in terms of tons per acre. Likewise, if the pH is very high in terms of alkaline, we need to apply gypsum to lower that pH so that certain nutrients also becomes available to the plant.
Knowing the right amount of mixture of fertilizer is crucial. especially when applying multiple fertilizers to the crop. Fertilizer application in the conventional method was applied under flooded fields. However, today it is the reverse with the implementation of the 6 points practice. Studies have shown that applying nitrogen fertilizer on the flooded field results in 50% of it being lost into the atmosphere.
When urea is applied under flooded conditions, that urea basically melts in the water or dissolves in the water, and right away you will have the nitrogen being lost to the atmosphere due to ammonium volatilization.
There are two methods of applying fertilizer, manually and mechanically. It is important to note that before applying the first dose of fertilizer, it is recommended to spray for weeds.
Now, immediately after the weed management, we applying our nitrogen fertilizer, which would be our first application of fertilizer, which done around 18-21 days. And we applied the nitrogen fertilizer on dry or moist soil, as you see it in the field already, how the field is. So we're using a mechanical spreader, and the rate that we're using here is 110 pounds per acre urea.
Using the mechanical spreader has its advantages. It saves time, labor cost, and can cover much more acreage effectively. However, there might be some concerns about driving a machine through a rice field without causing any damages.
Now you would notice that the tractor going into the field with an iron wheel, and it would be assumed that there was a lot of plant damages, but for wheat there's little or none at all, because this rice plant is still young and it's in its tillering stage. So those areas that damage, the plant tillers and it fill back those gaps. So you have nothing to lose actually.
If fertilizer is being applied, you need to flood the field within 3 to 5 days after application. In addition to that, it is not recommended that you drain fields immediately after or prevent the fields from drying out or having cycles of dry and wet, dry and wet. If that situation do occur, you can only realize about, say, 30 to 40% of the applied fertilizer. The plants will only benefit from 30 to 40%. As if when the crop is being completely flooded, 3 to 4 inches water after fertilization, and retain that flood until when the next application of fertilizer is required. In that way, you can get about 50 to 60% recovery of the fertilizer applied. So water management is equally important in terms of nutrient management of the rice crop.
Rice is an aquatic plant, which is why water management plays an important part in its cultivation. The seeds are sown in flooded fields but do not remain underwater for the entire crop.
The general management of water in rice cultivation is that farmers will broadcast pre-germinated seedlings into a flooded or shallow flood field, approximately 3 to 4 inches of water. And after sowing, based on the objective in terms of whether the field has red rice or grass weeds or not, he will make that decision whether to drain that field immediately or how long after sowing he should drain the field. And if he drain the field, how long after he is required to reflood or irrigate the field. So in a system where red rice needs to be managed or grass weeds, the farmer will maintain a flood of 3 to 4 inches of water for a prolonged period at the early stages of the crop establishment period. and more or less so for about 30 to 35 days. By then, the rice will establish itself, having a good spread of canopying effect, and hence reduce the establishment of red rice and other grass weeds.
There are two major aspects of water management: having nutrients available in a solution form for plants to absorb when needed, and as an agent for effective weed management. Water is a vital element needed when fertilizer is applied to the field. Even though it is recommended to apply fertilizer on dry and cracked field, water is needed to help the plants to absorb the nutrients.
Water is very important to be present in the field after fertilization. The general recommendation for application of fertilizer, especially urea, it is 18 to 21 days after sowing, 42 days, and 60 days after sowing. Now, if urea is being applied to the field and water is not present, let's say for 3 to 5 days maximum after application of fertilizer, we can have losses occur due to volatilization. So it is recommended that water irrigate to the field within 3 to 5 days after any nitrogen application.
During this process, all this time, that water serves to trap these nutrients in the soil and keep it there. It's like what we call a bank, where once it's trapped there, once the plant needs it, it's removed in small quantities as the plant needs it.
In the event that a farmer will drain the field just to encourage uniform establishment, when reflooding the field, he must gradually irrigate the water so that he does not drown the plants. As the plant increases in height or age, the water requirement is increased. So as every week after, or as the plant progresses in terms of size or height, there is a necessary increase for irrigation. The other concern too about water, it is that some of the soils may be saline, and the source of irrigation also, sometimes the water is saline, and the rice plant can only tolerate a certain amount of salinity, and that is about 700 to 800 parts per million of salt. So if we irrigate salt water of that extent of salinity, they will have negative impact on the growth of the plant. And salt water basically affect the plant at the early seedling stage and tillering and at flowering. So it is very important that the farmers get the irrigation water tested, especially in a dry season, when after the soils are being dried out, the salt moves from the lower surface to upper surface, and once it's within the root zone, they can accumulate on the plant roots and cause negative imbalances in nutrient uptake and so on, and as such have negative effects on plant growth. So it is very important to monitor the water quality by testing the level of salinity, and once it's below 700 to 800, it is good enough for a healthy rice crop growth.
Water can have both a positive or a negative impact on plant growth. But once the stages are followed according to the requirements, farmers will benefit in the end. That's all for this week's edition of The Science of Rice. I'm Carl Gurusamy. Thanks for watching.